Hey guys, how you doing? Okay, so this whole section is on distance time graphs, and more specifically it is on representing motion. So I'm guessing you probably feel something similar to Dave here. Dave is a T-Rex. He doesn't particularly like distance time graphs. He finds them really annoying, so he's always shouting at them, but that doesn't really help. So distance time graphs, what are they? Well, distance time graphs are a way of representing the motion of an object, not the emotion, the motion of an object in a graphical kind of a way. And the first thing to notice about distance time graphs is what's on the axis. So if you notice along the y-axis or the vertical axis, that's where we put the distance. And across the x-axis, that's where we put the time. Now again, that can be a little bit confusing to look at when you start out. So what we're going to do is we're going to jump ahead and just show you guys what the cheat sheet looks like first. So for a distance time graph, the cheat sheet looks a bit like this. Okay, when you've got a distance time graph, if an object, if a graph looks like this, if it's a flat line like it is in A, what that means is the object is stationary. In other words, it has stopped, it is not moving. If, on the other hand, you've got the line is coming up like this, what this means is that it's moving at a constant speed. So constant speed, that could be like 5 meters per second, 10 meters per second, and it's positive, which means it's moving away from the start point. So the start point is down here somewhere, okay? If you look at C, on the other hand, C is coming down what looks like a hill, but it's not a hill. This is also moving at a constant speed, but it's moving back towards the source, back to the start at a constant speed. Now it's worth you guys writing notes on this, okay? D is a little bit more interesting. D is when the distance per unit time seems to be increasing over time intervals. So if you notice, it doesn't go very far in, say, the first unit of time, but in the next unit of time it seems to have gone a bit further, and the next unit of time it's gone a bit further again. So that's an acceleration. In other words, it is speeding up. This, E, on the other hand, this is also an acceleration, but this time, if you break it into even sections of time, then you'll see that the distance is still increasing, but not as much. Every time it's going, it's getting just a little bit further away every time, and that means that it's slowing down. And F, well, if you guys have a look at F, which one of the previous examples is F? Give it a shot yourselves. Yes, F is a positive velocity, constant speed that is moving away from the object. Okay? So I hope you guys have taken your notes on that, because in the next little video we're going to jump back over to Dave and we're going to see about plotting out his journey and see if we can understand what exactly his journey looks like. So again, distance time graphs are a way of telling a story about motion by using a graphical method. You've got distance on the y-axis and time on the x-axis.